This is a how to build video for the depth perception and sustainment system, or DPSS. First thing you want to do is set up your breadboard. You'll notice that on either side of the breadboard we have a ground, negative power supply, another ground, and a positive power supply. I've connected the grounds here for simplicity reasons. However, you want to keep your negative and positive power supplies separate. On the back here you'll notice that the negative power supply and the ground are connected together to go to the negative section of our connection for the 9-volt battery. The next part is centering your chip. You want it on the opposite side of this groove so as to separate the separate ends of the prong. You also need to create a power supply. The center prongs of this particular chip, which is an LF347, needs to have a negative power supply, which is our red wire here running to our center prong on this side, and a positive power supply which runs to the center prong on this side. You need to make sure the orientation of your chip is correct, that the notch, which is over here on this side, is facing that direction. If you were to put the chip in separately, you would need to switch that direction. Refer to your data sheet that I've provided in the DPSS booklet so that you know where those power supplies need to be placed. Next, we need to set up our Wheatstone bridge. Since we haven't built our strain gauge system yet that's going to measure our depth, we're only going to be partially done with this at this point. Our potentiometer has 3 prongs, however we only need 2 of them. This first one and the center one. We can ignore the third prong. After putting it in your Wheatstone bridge, you want to run a positive power supply to the outer prong. The center prong will then be connected to your resistor, which will run to ground, connected here with a second resistor that'll be in an open space. The connection between your potentiometer and your resistor will then be run to a section just outside your chip. And the later connection between your strain gauge and this resistor will be connected in this spot right here. The next part is creating your differential amplifier. The connection between your potentiometer and your resistor will be connected to this resistor right here, which will then run to our third prong, which is our positive source. Our connection between our resistor and our strain gauge will connect to this resistor, which run to our negative source in the operational amplifier in our chip. The next resistor right here, as it can be seen, I have the prongs bent underneath the resistor so as to connect the first prong of your chip and the second prong of your chip. Make sure these prongs do not touch, as it will change the resistance and create a short across this resistor. The final resistor is this one right here, which will run from your positive part of your op amp and run to your ground. That is the third prong you want to run that from. The source from your differential amplifier will run out of your first prong, as seen by this green wire. This green wire is then separated into 2 different green wires, as they will be the source for our Schmitt trigger. First part of your Schmitt trigger, however, is going to be creating your voltage reference, which will be coming from our 9-volt battery. As can be seen here, I have 2 wires coming from our positive voltage supply, which then run to these 2 different resistors. These resistors will run to the positive source or third prong on our chip. You can see that they're separated. These two triggers will be separated by the center prong here. The third chip in will be for this Schmitt trigger, and the third chip in will be for this Schmitt trigger. For our red LED, this one here, we want also this resistor to run from our output, which is our first prong here, and then run to our positive or third prong here. The third and last prong will run from our positive to our ground, and you can see here the green wire, which is our output from our differential amplifier, will run to our negative input, which is the second prong right here. Then you can add your red LED to the output, our first prong here, to ground. Next we want to create the section for our green LED, which is this one here. We have the power supply running to this resistor, which will run to our third prong, or our positive input here. Now this one's a bit different because we don't have a resistor that matches the correct value that we need for our second resistor. So as you can see here, we have two resistors, and how resistors work is if you put them in series or one right after another, their resistance will add. So we have this resistor that runs from our output, or our first prong here, will connect with a second resistor here that will then run to our positive input, or third prong. Then lastly we have this resistor that will run from our third prong, or our positive input, to ground. Once you have that configured, you can put in your green LED that will run from your first prong or your output to ground. And that's setting up your circuit. The next part will be creating your strain gauge that will measure depth. This is an example of the strain gauge, however the one that you will be using in the DPSS will be twice as big as this one. You also want a syringe such as this, or other containment system that will be waterproof. So you can see here you want to place a slit at the bottom of your syringe so that the strain gauge can be slid through and reach to the top. Next, you want to make sure that that strain gauge stays in place, so you will glue your strain gauge in place, also gluing the end of your syringe so that no air can escape and water enter into your syringe. This part right here, you can see I have a strain gauge setup already made. You want to then, once the strain gauge is in place, cut your syringe at a good length that the strain gauge will be bent slightly to give you an added resistance. Then, now you see here, you want a section that will allow the balloon to push down on your strain gauge. Mine is just some glue from a hot glue gun to create a surface area for the balloon to press down on. Then you want to slide your balloon over the top, gluing it to your strain gauge so as to allow the balloon to press down better on your strain gauge. You do not want to tighten the balloon down very tightly. If you do, it'll create a greater depth that the DPSS will have to go before it starts giving you results. Lightly place it over and cover it up with tape. I do recommend a better tape than this electrical tape that I was using, as it does leak slightly. The bag for waterproofing, doesn't need to be very special. I bought this at Sportsman's Warehouse. It's just a simple waterproof bag. You'll make a slit at the top of the bag where you'll put in the prongs for your strain gauge, and as can be seen there, and you'll glue it shut so that no water can enter in the bag. Once that's done, you can place in your circuit, reattaching the prongs that you've attached to your strain gauge, and connect your battery, seal up the bag, and you're ready to rock and roll. And that is how you build the DPSS, or Depth Perception and Sustainment System.